Subscribe to the channel and press the bell icon so you never miss any updates from us.
In this video, we will talk about the very important topic of the organic chemistry, hydrocarbons. Hydrocarbons are simply organic compounds that contain just carbon and hydrogen atom. All the hydrocarbons contain just these two atoms, carbon and hydrogen. Due to the self-linkage property of the carbon, that is known as catenation, a large number of compounds exist in the nature. Millions of compounds exist due to this self-linkage of the carbon atom, that was known as catenation, due to which we divide these hydrocarbons in different groups like hydrocarbons, aromatic compounds, carboxylic compounds, alkyl halides, alcohol phenols, ether extras. So let's see what are hydrocarbons. Hydrocarbons are simply, we discuss here, the carbon and hydrogen containing compound. Let's we start with a simple organic compound called methane. We also written this. If the as we know that the carbon has the valency of 4, 1, 2, 3 and 4. The carbon has the capacity to form 4 other bonds and add 4 hydrogen into this carbon. If there is 4 hydrogen atom in this, so in this molecule all the carbon valencies are fully satisfied, so we cannot add any other hydrogen atom in this carbon. So this is called saturated hydrocarbons. And another way, let's we take an ethene, ethene have the double bond with carbon and 2 hydrogen on each carbon. In this there is a capacity to add another hydrogen in this compound. Similarly, in ethane we can also add another hydrogen. Ethane has triple bond. In this molecule we also add another hydrogen atom. So these two are called unsaturated hydrocarbons. So in these molecule the carbon valency is not fully satisfied and have the property to add another hydrogen into that compounds, ethene and ethane, and these are called the unsaturated hydrocarbons. These are the first class of hydrocarbons, alkanes. These are also called paraffins and have the general formula CN H2N plus 2 the simplest जो alkane compound is methane, and in which all the carbon valencies are fully satisfied, so these are saturated hydrocarbons. So let's start the nomenclature of alkane. This is the scientific way to give the name of the alkanes. In the nomenclature rule, first we see the longest chain in the compounds by giving the numbers to the carbon atoms. Let's start from one side: 1, 2, 3, 4, 5, 6. And another way to give the name of this hydrocarbons is 1, 2, 3, 4, 5, 6. In both cases the chain is end with 6 carbon, so this is called the hexane molecule. But if we starting from here to here, then this is methyl substitute. So and we give this substitute to the lowest number, so we follow these lines. So this is 2, this is known as methyl group, so we give this 2 methyl hexane. Let's we take another example. In this we give the numbering of the carbon. Let's start from here: 1, 2, 3, 4, 5, 6. So another way to give the numbering of this carbon is that 1, 2, 3, 4, 5, 6, 7. So the longest chain is this one. So this is substitute, that is methyl, and at the position 3, so we give this 3 methyl heptane. Let's we renew this one. Select, first of all select the longest chain of the carbon atoms, then give the lowest number of the substitute that was attached to the carbon. So we will take, see here, the methyl group is the nearest to that carbon, that is 2. So we starting from the numbering of in this way. So this methyl group is nearest to the carbon 2, so we need to write the position of carbon 2 and methyl. The substitute is always written first and then the name of the parent chain. This was the name of parent chain, that was original chain of the carbon. So the substitute name is written first and then second, the parent chain name is written later. Similarly, in this example, the substitute take the number 3 and this symbol is hyphen to separate the group. So this substitute is nearest to the carbon 3, so we select this chain of the carbon and return the name of this substitute first and then later at the parent chain. If there are two or more substitutes on same carbon like this, let's we start the numbering of this compound 1, 2, 3, 4, 5 and 6. So if we starting the numbering from here 1, 2, 3, 4, 5, 6 and the same numbering is also here. So we see here there are two different groups on the same carbon. These 3 carbon have the ethyl group and this one is the methyl group. If the possibility of this kind is exist, then we use this number 3 number carbon twice, 3, and this is ethyl group and this is methyl. So we decide which one we take the substitute as first. Is see the alphabetical number, as E is first then the methyl M, so we return the ethyl group first then the methyl group. So 3 ethyl and then 3 methyl, and the name of the parent chain is hexane. If there are more than one substitute, if we numbering this carbon 1, 2, 3, 4, 5, 6 and these substitute present on this carbon is written as alphabetically, as ethyl group is present here and methyl group is here. So we start 4 ethyl and 2 methyl hexane.